Hi dear students, how did you write the morning session exam? From the feedback of the students, it is with mixed, a sort of mixed weightage. It is not so tough, not so easy. People are saying average level paper. So that mixed opinion is coming up from the students. The weightages are as usual, everything whatever we are discussing is based upon the memory oriented feedback from the students. And this memory oriented feedback is again based upon the people we have interacted. So based on that, this is the approximate weightage of different subjects. As usual, the weightages are coinciding with the previous year weightages, the as usual weightages of GATE exam. Geotechnical engineering got the highest weightage, and after that you see 5 questions of 2 marks and 3 questions of 1 mark. After that, as per the data collected, the transportation has got the next highest weightage. After that, most probably it may be the parallel weightage to the environmental engineering. So 3 2 marks and 3 1 marks. As per the present data, once the total paper comes out, we can tabulate the final weightages, but these are approximate weightages. And as usual, general aptitude and English and mathematics, this is the weightage we have taken from the feedback. 4 2 marks questions, 5 1 marks questions. These general aptitude is fixed, and maths has given very good weightage, and after that GT, transportation and environmental as usual. After that, you can see the hydrology and irrigation is having 4 2 marks questions. That's what the feedback we got it. It is also a good weightage in this year. Now coming to the structural analysis, 3 2 marks questions have come into the picture. It is also a good weightage. And solid mechanics, 1 1 marks question, 1 2 marks question. This is slightly lower as per the feedback we got it. Now coming to the engineering mechanics, 1 2 marks question. Usually the mechanics and strength of material will share the weightage, that you know already. So approximate weightages are shown up here. This may drastically change based upon the final opinion and the final paper which is coming out. This is purely memory oriented. Whatever data we are presenting may not be correct. Even the type of question may not be correct sometimes. So if at all any problem is there, please excuse. But however, we'll try to give you the accurate data based upon the accurate feedback coming from the students. And this discussion is just gives you a sort of clarity, and you can make a sort of opinion upon your score and your future results. So as per the present data, we'll talk about first the surveying. In surveying, as per the data, this is the question from the leveling. The following staff readings were taken at 20-meter intervals. 20-meter intervals, they have taken the levels. Distance between one level to another level is 20. The values are given. If the instrument was shifted after the 6th reading, the gradient of the ground joining first point and the last point they are asking you. The gradient they are asking you. So the change point is after 6th reading. 1, 2, 3, 4, 5, 6. After this is a change point. So first reading whatever we see is backside, and intermediate, 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 and this is our foresight. Next, after change of the instrument, now coming to this is our backside of the same point of this one, and then this gives you the foresight, and these things are intermediate sites. Okay, so intermediate sites are only to identify the distance between the first point and last point. So here to here 20 meter, here to here 20 meter, here to here 20 meter, here to here 20, and then this to here 20. That means 20, 40, 60, 80, 100 meter in the first setup. And after change of the instrument, this is from this point only. So here to here is 20 meter distance, 20 meter distance, and then 20 meter distance. So next is 60 meter distance. 1, 2, 3, 60 meter distance. Now coming to the elevation difference in the first setup, so this minus this will give you the elevation difference 4.850 minus 0.385. This is the elevation difference in the first setup, and the next elevation difference in the second setup is the backside is 1.045, foresight is 4.580. Actually it is a sloping down the terrain, because the values are gradually increasing from first to the last. So it is 4.580 minus the backside 1.045. So this is the total distance covered, so total elevation difference between first point to the last point, and the length is nothing but 160 meter. And if you want to express the gradient as a percentage, you can multiply with 100. So if you simplify, the length of the gradient can be taken equal to 3.125. Memory oriented values, you know, it's very hard to remember these values exactly, and they have to remember the values, and after the exam, after the 3 hours, they have to come back and jot down this on paper, and they have to forward it. There may be chances of discrepancies, but this is the method by which we need to calculate the gradient. Okay, a regular procedure. People having a good fundamental on the leveling work with little aptitude, you can get the answer directly. It is not a critical question from my point of view. Even most of the people say the same thing. Most of the topper students will also say the same thing, but little logic is required. But however, GATE is graduate aptitude test. People with aptitude will win the game. Coming to the next question, a 1 mark question again from the leveling. From leveling this year, it seems 3 marks means, previous was a 2 marks question and this is 1 mark question. 3 marks means a good weightage, relatively good weightage from leveling topic of survey. Now look at this question. The foresight reading upon a point A was 1.5 meter. The foresight is 1.5 meter. Now next is the height of instrument is 100 meter. So RL of the height of instrument is nothing but 100 meter. Height of instrument or height of line of collimation, RL of line of collimation is 100 meter. The RL of the point A they are asking you. It is again a very aptitude, basic level aptitude question. No need of any theoretical background, no need of any formulae. Directly, so RL of A is equal to 100. You need to come down to get the point A. 1.5 you need to come down. 100 minus 1.5 if you come down, that is 98.5. Is it okay? Okay. 98.5 meter. straightforward. Within 20-30 seconds you can answer such question. Very straightforward, simple question from leveling point. Now coming to this question, 30-meter tape is standardized at a temperature of 25 degrees centigrade. This is a standardized temperature. That means at 25 degrees, the tape shows you exactly 30 meter. If the temperature at the time of measurement was 35 degrees, that means you are using the tape at a higher temperature. So the delta T will be 35 minus 25 is 10 degrees temperature. You are using the tape at 10 degrees centigrade higher temperature than the standard temperature. That means the length of the tape is too long at the time of measurement because of temperature is high. If you measure the distance with a too long tape, the measured distance will come down, so the correction is positive. Positive correction is required. How do you calculate the correction? The change in length, this formula you might have used in strength of material also, L alpha delta T, the change in temperature. So in length of the tape is 30 meter. They are asking you the answer in mm actually, in millimeter. So 30 into 1000 millimeter. Quotient of thermal expansion of the steel is 1 into 1.1 into 10 raised to minus 5 is given. Delta T is 10. So if you simplify with your online calculator, it becomes 3.3 mm. So the length of the tape is 3.3 mm more than the actual 30 meter. So if you are measuring with a too long chain, the measured distance may be less. So for each and every chain length, we need to add 3.3 mm. So the correction is positive correction. Answer is 3.3 mm. I hope they have asked only the magnitude of the correction. If they are asking you magnitude of correction with one decimal place, you just print here 3.3. So as per the memory oriented data, take it as 3.3. Okay. Now coming to the next question. This is what we have taken from the, we have got it from surveying. Next one question came from strength of material. Regarding shear center. A similar question is coming from the last 2 years. They asked, it seems, the shear center for the channel section. For a channel section, the shear center is the junction of flange and web. This you know. So they have given some options in the multiple choices. You need to pick up the answer as the point which is representing the joint, intersection of flange and web is our shear center. Last year it seems they asked shear center for a T section like this with uneven flanges, and previously a long back they asked a complete shear center of the T section. For all the group of cases, the shear center is the junction of flange and web. That is a known concept. The people just gone through the shear center chapter will definitely answer this. You can spend hardly 10 to 15 seconds to answer such questions. Not a very critical question, please. It seems in RCC they have answered, they asked a question like this. RCC. In case of RCC, they asked a question regarding the deflection due to sustained loading, 1 mark question. RCC, deflection due to sustained loading is called constant loading with the time. Deflection due to sustained, nothing but constant load. It won't come overnight, it comes with a time. What is this called? This is a common definition, 1 mark question. It is called creep. Creep comes with the time, it won't come all of a sudden, and moreover it comes with constant loading which is there over a long period of time. Okay, especially with long term we get this creep. This is a common 1 mark question of RCC. Okay, the other questions with the available data, the next faculty member Mallikarjun will take up.
Hi everyone, now we'll see the structure analysis subject. So students told gate students, so number of questions from this subject is 3 questions, and these 3 questions are 2 marks question, then total 6 marks from this subject, but we received only 2 questions from this subject. Okay, right. So very simple questions. First question from plastic analysis chapter. So he asking you to find the plastic sectional modulus. Okay, so this is a T section given. So these are symmetrical section, right, about horizontal axis. Okay, so what is the formula to find the plastic section modulus? Plastic section modulus equals to A by 2 y bar C plus y bar T. Okay, so students, y bar C and y bar T are centroidal distance under compression and tension area from plastic neutral axis, right? First we have to locate the plastic neutral axis for a given diagram. Okay, students, for symmetrical sections, elastic neutral axis, plastic neutral axis both will coincide, right? Okay, so this is symmetrical about horizontal axis. So this is the elastic neutral axis and this is the plastic neutral axis. Okay, now this is the area under compression, this is area under tension. First look at the centroid under compression. This distance is y bar C. Okay, so y bar C value is here 10 mm. Then look at the CG under tension from plastic neutral axis. This is y bar T. So what is the y bar T value? This is given 100, right? Then this is 50 mm. Okay, right. So plastic section modulus equals to, here total area we have to find first. What is the total area? Here it is 2000, here 2000, total 4000 mm square by 2. What is the y bar C value we got? 10 and y bar t value we got 50. And if you solve this one, you will get 120 into 10 to the power of cube mm cube. Okay, so this is the first question. Right, now we'll see the second question, and very simple question. So given is a determinate structure. So I told to analyze the determinate structure, simply equilibrium equations are sufficient, right? No need to use the methods like movement distribution method, slope deflection method, etc. If it is indeterminate structure, yes, we have to apply the methods. Okay, so this is a given diagram, frame given, rigid jointed frame. Okay, he asking to find the bending moment under 90 kilonewton. Okay, so for example, this is point E. We have to find the bending moment at point E. To find the bending moment at point E, either look left to the point E or right to the point E. You'll get the same answer, right? But to save the time in examination, better look right side. Reason is, right side only one reaction is there, it is RB. But if you look left side, hinged support, two reactions, right? HA, RA. Okay, if you look right side, only thing is we have to find the reaction RB. Once you know the reaction RB, then we can find the bending moment at point E. How to find the reaction RB? Take moment about hinged support. Now, taking moment about A, so anti-clockwise negative, clockwise positive. Our target is support A, right? Now here, RB clockwise or anti-clockwise? RB towards support A. This is anti-clockwise, right? What the perpendicular distance up to support A? Perpendicular distance is 2 plus 2, it is 4. Okay? Next, 90 clockwise or anti-clockwise towards support A. This is clockwise, right? So plus 90 into what the perpendicular distance? This is given 2. And here there is a horizontal load also there, 50 kilonewton. This is clockwise or anti-clockwise? This is clockwise. Then perpendicular distance is 3. So here plus 50 into 3 equals to 0. Then how many unknowns are there in this equation? Only one unknown is there, that is reaction RB. Now find, if you solve this one, you'll get the reaction RB is 82.5 kilonewton. So we got positive, then assumed direction is correct, it is upward only. Now we can find the bending moment at point E. Right, so bending moment at point E, just force into perpendicular distance, right? So RB into 2, so 82.5 into 2. So this you will get 165 kilonewton meter. Okay, so students, this is the data received from the GATE students. Okay, so these are the two questions we received from GATE students. Okay.
Now, from the geotechnical engineering, total 8 questions appeared in morning session. Out of them, 1 mark questions are 3 questions and 2 marks questions are 5. So total 13 marks appeared as of the information we got from the students. Now let's see the questions. So here, according to Rankine's earth pressure theory, for a passive earth pressure, what is the angle with the major principal plane? So here the terminology is quite tricky. If you miss that, you will be end up with a different answer. What they're asking is the angle with the major principal plane, not about horizontal. So whether it is active case or passive case, if the question is asked about the major principal plane, answer is always 45 plus 5 by 2. Now you see, if this is a soil element, now this is a vertical stress and here is a lateral earth pressure. In case of the passive state, the lateral earth pressure is major principal stress and vertical stress is minor principal stress. So if this is the major principal stress, whatever this plane, this is major principal plane. There comes. Most of the students, what they do is they miss the point. See, what is the angle with the major principal plane? This is the major principal plane, and if this is the failure plane, whatever this is alpha f, which is the angle made by the failure plane with respect to major principal plane. Now with respect to horizontal, if this is 90 degrees, now what is this value? 90 minus alpha f. So what is alpha f? 45 plus 5 by 2. 90 minus alpha f is 45 minus 5 by 2. You miss the point of major principal plane, you will be getting a different answer. So for this question, the answer is 45 plus 5 by 2. Similar question was appeared in previous gate also. Now see this question. This is an MCQ question, but we got 3 options. So let's see what are the correct statements out of these 3. In the context of the shear strength of a soil, which of the following statement is correct? Okay. The UCS test means unconfirmed compressive strength test, is a special case of UU triaxial test. Yes. So in the case of the UCS test, what we do? We don't apply any cell pressure. That's the reason why we call it as a special case. That's true. Now, the shear strength parameters obtained from the CD test should be used to analyze a rapid construction in the clay. In the case of the rapid construction, when we apply rapid construction, water will not get enough time to go out, which means it is an undrained condition. But you see CD test, that is a consolidated drainage test, which is a completely drained test. Generally, we use the CD test to check the long-term stability. But as they're asking about the rapid construction where the water will not go out, that creates undrained condition. So CD test is not suitable. The best answer would be UU test, not the CD test. So option B is incorrect. Now, vane shear test is commonly used for determining in situ. In situ means in the case of the field. And undrained shear strength of the saturated clay. Yes, vane shear test can be done both lab and field, but especially in the case of field, out of all the tests, this test will give us undrained shear strength for the clays. So the third option is also correct, as we haven't known about the statement D, but as of now, out of this question, A and C are correct. Now, for a sandy soil having a void ratio of 0.6 with a permeability coefficient as 0.14 centimeter per second, considering the same soil, now if the void ratio is 0.8, what would be the coefficient of permeability? For same soil, the relation between the coefficient of permeability and void ratio goes as K is proportional to E cube by 1 plus E. Now, mention is K1 as a 0.14 centimeter per second and E1 as 0.6. So what would be the K2 if the void ratio is 0.8? Now let's apply that equation. K2 by K1 is equals to E2 by E1 whole cube into 1 plus E1 by 1 plus E2. Right. Now substituting these values, K2 is 0.8 by 0.6 whole cube into 1 plus E1 0.6 by 1 plus 0.8. So into 0.14. You solve it. Calculator. Okay, so you solve it, you'll be getting the answer as 0.294 centimeters per second. If the question would have been asked with around 2 decimals, then you can go with a 0.29. Now see this question appeared from the soil exploration. To obtain an undisturbed clay soil sample, the area ratio is 10%. So given the area ratio itself is a 10%, area ratio 10%, and outer diameter D0 is given as 50.8 mm. So what's the question they're asking? What will be the inner diameter? It's a quite simple question, direct formula. Now you know area ratio is equals to outer dia square minus inner dia square by inner dia square into 100. As they're asking about the inner dia, split that. If you split that, then D0 by di whole square minus 1 into 100. Send the 100 to the other side, 10%, 10 by 100, which is going to be 0.1. 0.1 is equals to the outer diameter 50.8 by inner diameter whole square minus 1. You send the minus 1 to the other side, then you will be ending the answer. The inner diameter comes as 48.43 mm. So the correct answer is 48.43 mm. If it would have been NAT, 48.43 mm, based on the 1 decimal or 2 decimal, you can opt it. If it would have been MCQ, choose that option. Now assume the skin friction capacity per unit surface area in the clay is given as Fs is equals to alpha into Cu. It's like the question, they have given the data, they have given the equation, everything, just you need to know is, you need to calculate, that's it. If a Cu is equals to 80 and alpha 0.5, what is the frictional stress? They are not asking about the frictional resistance, they are asking about the frictional stress. So Qs is equals to small qs into As, they are asking about the frictional stress, Qs is equals to alpha into Cu. They have given that Fs. Okay, so now alpha is 0.5 into Cu, which is 80. The correct answer is 40 kilopascals, option B. The skin friction capacity of a pile is proportional to which of the following? So now they're asking about skin frictional capacity. Skin frictional capacity is nothing but for a pile, especially in the case of the clays, alpha into C bar into pi d into L. First, perimeter, yes, the pile perimeter is nothing but pi d. Pile length, yes, that's also correct. Clay cohesion, yes, that's also correct. Now the pile end area is pi by 4 d square, that we will be using for finding the base resistance due to bearing capacity. So from the given question, the correct answers are A, B and C. Now match the following. So they have given the engineer or scientist names along with the tests. Now if you see the set 1 or list 1, the scientist or engineer's name who have proposed the test, and in set 2 the type of test. Here the pitot-o-meter, it's not a pitot-o-meter, it's a dilatometer. It is a dilatometer. Okay, so Menard proposed the pressure meter test. So for 1 it is Q. Marchetti, he proposed the dilatometer test. This we used in the case of the site investigations. So for 2 it is P. Casagrande, this is not WA, this is the WL, which is nothing but liquid limit test. For Casagrande it is S. Proctor test, which is a compaction test, so that's going to be R. Now these are the questions as of now we got from the geotechnical engineering. Once we got the remaining questions, we will be updating soon. The next questions will be taken by next faculty.
My dear students, now I consider the mathematics subject. As per the students received from the students, I can say that totally 13 marks were given from mathematics part. Out of 13 marks, 5 questions 1 mark questions, 5 questions are 1 mark questions, and 4 questions are 2 marks questions. 5 are 1 mark questions and 4 are 2 marks questions. Totally 13 marks. 13 marks were given from the mathematics part. Okay, this is according to the students' feedback. Now I'll discuss about the some questions received by the students. So far we have received only the 4 questions from mathematics part. Now let us discuss the one by one. The first question. This is a question from the differential equation topic. The general solution of the differential equation x square y double dash minus 6y equal to 0. It is a question from the differential equation topic, and also it belongs to this higher order. Finally, it is a Euler's equation or Cauchy-Euler equation, Euler-Cauchy equation or Cauchy-Euler equation. To find the solution of this equation, first we try to convert the variable quotients to constant quotients by the transformation, and then we find the solution by constant quotients. And also it is a just homogeneous equation. Because of the homogeneous equation, complementary function is the general solution. Complementary function is the general solution. So let us do this problem. First we express in operator form, that is x square d square minus 6 into y equal to 0, comma d equal to d by dx. The given independent variable is x and dependent variable is y. Now we try to express this in terms of the new variable by using the transformation x equal to e power z or log x equal to z, and xd equal to theta, comma x square d square equal to theta into theta minus 1. With these substitutions and this transformation, we can convert the variable quotients to constant quotients. After that, we write the solution. With this substitution, this becomes theta into theta minus 1 minus 6 into y equal to 0, which implies theta square minus theta minus 6 into y. The variable quotients is reduced to constant quotients. Up to your reduction is completed. Now we find the solution by constant quotients method, and this is in the form of f of theta y equal to 0. In short form, we write this as f of theta y equal to 0, where f of theta is this part. Now to write the solution of this equation, first we write the auxiliary equation. The auxiliary equation is given by f of m equal to 0. From this f of theta, we write the f of m, that is m square minus m minus 6 equal to 0. By factorization method possible to find the roots, we can find the roots. Not possible, we can use the general formula of quadratic equation, but here by factorization we can write the roots. The roots are product of the roots, sum of the roots. So 3 minus 2 is 1, 3 into minus 2 minus 6. The roots are 3 comma minus 2. The roots are real and different. So correspond to real and different roots, we write the yc complementary function c1 into e power 3z. The old independent variable x is replaced by the new independent variable z. So we write the solution first, or complementary function in terms of z, and then we express in terms of x, plus c2 into e power minus 2z. Now using this yc, we write the general solution. Therefore the general solution of the equation is y equal to yc in terms of x. Again replace e power z with x, e power z with x, z with log x, but no log x here. So we replace the e power z with x, c1 into e power 3z, that is e power z power 3, so x cube, plus c2 into x power minus 2, or 1 by x square. Now this is the general solution of this equation. So converting the variable quotient to constant quotient by the transformation substitutions, so that we can get the complementary function in terms of z, and then we express in terms of x. This is the general solution of this equation. This is about the first problem. Now we go to the next problem. The second problem is from linear algebra topic. The matrix is given like this, 3 by 3 matrix, A equal to 3 by 3 with the elements 1, 0, 1, 0, 1, 0, 1, 0, 1. These are the elements of the matrix. Now for this matrix, the 4 options are given and we are asked to choose a true statement. We are asked to choose a true statement. Now let me write the 4 options. Option A is a skew symmetric matrix. Option B, A transpose into A is an identity matrix. Next, option C, trace of A. TR of A means trace of the matrix. Trace of the matrix equal to sum of eigenvalues. Next, last option, absolute magnitude of eigenvalues is 1. So these are the 4 options. Every option is one statement. Now we are asked to choose a correct option. For this given data or given matrix A 3 by 3, we check this is correct or not, this is correct or not, this is correct or not, this is correct or not. Now first, what is the first statement? The first option is A is given that skew symmetric matrix. Now to check this matrix is skew symmetric or not. According to definition of skew symmetric matrix, the condition for skew symmetric using the element notation is Aij equal to minus Aji. Okay, A12 equal to minus A21 like that. And for diagonal elements, Aii equal to 0. If you replace J with I, then Ai equal to minus Ai. That is Aii equal to 0. Diagonal elements of a skew symmetric matrix are always zeros for skew symmetric matrix. But here diagonal elements are not 0. Therefore, it is not a skew symmetric matrix. So this is wrong statement. According to skew symmetric, diagonal elements should be zeros. But here diagonal elements are not 0. That is why this A is wrong. Next, A transpose into A is identity matrix. First of all, it is the condition for the orthogonal matrix. A into A transpose equal to In. For this 3 by 3, here I3. For nth order, In. Next, A transpose into A for nth order matrix. For a square matrix of order n, this condition satisfies. So we can say the matrix is orthogonal matrix. Here given that A transpose into A is identity matrix. That means I have to check this matrix. He is saying that this matrix is orthogonal matrix. Because of the orthogonal matrix, if you want to say that directly the matrix is orthogonal matrix or not without checking this condition, you have to check every column is a one vector, every row is a row vector. Now if you consider these two column vectors, between these two dot product is 0. But between these two dot product is not 0 only. Between every two column vectors dot product should be 0. That is the first condition for orthogonal. But the condition between these two vectors, orthogonal condition between the two vectors first and last is not satisfied. So it is not a orthogonal matrix. Therefore this is wrong statement. Next we check the third statement. According to one of the properties of eigenvalues, eigenvectors, for every square matrix, trace of the matrix is same as sum of its eigenvalues. Sum of the eigenvalues of the matrix equal to sum of its diagonal elements. Sum of the diagonal elements is same as trace. So this is the correct statement. Trace of the matrix or sum of the diagonal elements must be same as sum of the eigenvalues. This is a correct statement. Next, absolute magnitude or absolute value of the eigenvalues must be 1. That is possible for orthogonal matrix. But here, first of all, it is not a orthogonal matrix. Whenever it is not a orthogonal matrix, this is also wrong. If it is orthogonal and if you find the eigenvalue, after finding the eigenvalue, if you take a modulus, that should be 1 only. First of all, it is not a orthogonal matrix, so this is wrong. Out of 4 options, only the C option is true statement. Now let us move to the next problem. Third question. It is a question from the numerical methods. The given equation is e power minus x equal to 0, and the first approximation is given as x1 equal to 0.5 or 1/2. For this equation, transcendental equation, we are given that first approximation, and we are asked to find the second approximation. We are asked to find the next approximation, x2 approximation by Newton-Raphson method or NR method. According to Newton-Raphson method, we try to write the approximate value of the root of the equation. Let us take this as f of x. From this equation, let f of x equal to e power minus x, and x1, the first approximation is taken as the 0.5, that is given approximation. Then according to Newton-Raphson formula for finding the second approximation, we require the first derivative of the function also. So we write the first derivative, f dash of x equal to minus e power minus x minus 1. Now the next approximation or second approximation with the given first approximation is given by the formula x2 equal to x1 minus f of x1 divided by f dash of x1. Right? This is the formula for finding the next approximation to the given first approximation or second approximation for a given first approximation. Now according to this formula, we substitute all these x1, that is this given approximation. We write the f of x1 from the function. We write the f dash of x1 from the function. So this is equal to 0.5 minus f of x1 is e power minus 0.5 minus 0.5. Just replacing this x1 with this 0.5 in the function f of x f dash, and we can simplify this. In the denominator, minus e power minus 0.5 minus 1. Now after simplifying this, at the end the required approximation up to 2 decimal places. We don't exactly it is asked to find the 2 decimal places or 3 decimal or 4 decimal places, but here I am writing the up to 2 decimal places. At the end of the simplification, this is 0.55 up to 2 decimal places. Sometimes it may be depending the calculation, depending the taking the number of decimals after decimal, taking the depending on the number of digits after decimal places, we can get the 0.56 or 0.54, 0.55 like this. Okay, it may vary on. Anyhow, for if it is numerical answer question, the range will be given. You may find this in that range also. So this is the second approximation to the real root of the equation with the given first approximation, or it is the next approximation to the given first approximation. So this is about the third question. It is a question from the numerical methods. Now let us go to the next problem, the fourth problem, that is also from the numerical methods. Some data is given in the form of table. X, y equal to f of x. 3 points are given. The first point is minus 2, 28, 1, 4, 2, 16. Okay, minus 2, 28, 1, 4, and 2, 16. Exactly we don't know whether some values are same or not, but we have received that like this. This is the data. Now we consider this as x0, this as x1, this as x2. Corresponding function values are, let us suppose this y0, y1, y2. It is a given data for a function. How many points are given? 1, 2, 3. 3 points are given. Next, the question is, if P2 of x, P suffix 2 of x represents a second degree interpolating polynomial for the function y of x or y equal to f of x. If this is a second degree interpolating polynomial represents this function y equal to f of x or y of x, then the value of P2 of x at x equal to 0. So we are asked to find the second order polynomial interpolating polynomial function value at x equal to 0. That is, indirectly it is asked to find the P2 of 0. Just we are asked to find this. Now to find this, we can use the forward difference or backward difference or central difference or interpolation formula, or we can use the Lagrange's, or we can use the Newton divided differences, but the particular formula depends on the x, that depends on the particular x sum. That is, if this is equally spaced data, we can use any one formula. If it is unequally spaced data, then you have to use the either Lagrange's interpolation or Newton's divided difference interpolation formula. Now first we check whether the interval of each, that is the space, equally spaced data or unequal spaced data, is given by the difference of the two consecutive values of x only. The difference of these two consecutive values of x is not same as the difference between these two consecutive values of x. That is, it is unequally spaced data, not equally spaced data, because the difference of every two consecutive values of x is not same. That is why it is unequally spaced data. For this unequally spaced data, if you want to find the interpolating function or interpolating polynomial value at x equal to something, we use the Newton's divided difference interpolation formula or Lagrange's interpolation formula. If you want to use the Newton's divided difference interpolation formula, we have to form the difference table, and from the table we consider the function values and x values. Without that table, if you want to do the problem by Lagrange's interpolation, also we can do the problem. But for Lagrange's interpolation formula, we do not require any table. So here I try to write the Lagrange's interpolating polynomial formula for this given data of 3 points. Because of 3 points in the formula, we can find the 3 terms. So corresponding to 3 points, the formula will be like this: P2 of x is given by, correspond to first point, x0, y0, x minus x1 into x minus x2, x minus x1, x minus x2. In the denominator, x0 minus, we are writing this term corresponding to the first point x0, y0. So that is why in the denominator I am writing the x0 minus x1 into x0 minus x2 into function value y0 plus. Next, the next term is corresponding to second point x1, y1, x minus x0 into x minus x2 divided by x1 minus, we are writing this corresponding to second point x1, y1. That is why we write in the denominator x1 minus x0 into x1 minus x2 into y1 plus. The last term is corresponding to last point x minus x0 into x minus x1 divided by x2 minus x0 into x2 minus x1 into function value y2. Now substituting all these values, we can write the interpolating polynomial, and also if you substitute x equal to 0, in place of x write the 0, in place of x write the 0, in place of x write the 0, and write the x1, x2, x0 and y0, y1, y2. After simplification, this answer will be P2 of x equal to 2, right? So finally it is an interpolating polynomial function value for the given data. So this is about the questions from the mathematics part.
So hi everyone. So we received one question from students. This is a question given from design of steel structure, welded connection. Okay. In the question given two plates connected by 5 mm fillet weld, length is given 150 mm. Okay. So two plates, just these are the two plates, fillet weld is given. Okay. And size of weld is given 5 mm and length of weld is given 150 mm. Okay, right. So these are data first. If size of fillet weld for same plates is changed to 6 mm. Okay, initially size of fillet weld is 5 mm. Now for the same plates again given 6 mm. The weld length needed for the transferring same load. He asking to find the length of weld for same load. Students, for safety, load equals to strength only, right? Okay, then this is formula LW TT FU divided by root 3 gamma MW, right? Okay. Right. So from this we'll get the load. Okay. So what is the length of weld is given? 150. Effective throat thickness is nothing but K into S only, right? Okay. So K is depend upon angle between fusion faces. So this is 90 degrees, then this is 0.7 only, right? So 0.7 into size of weld is 5 and this is the 410 divided by root 3. So actually we don't know is it a field fabrication or shaft fabrication. Just assume this is the shaft fabrication only. So this is 1.25. If it is field fabrication, then you'll get this is 1.5, right? So from this you'll get the load P. Okay. So here is given this size of weld changed to 6 mm for the same plate. Okay. Asking you to find the length of weld for same load given, for same load. Okay. So here P equals to PdW equals to length of weld TT FU divided by root 3 gamma MW. Okay. So here substitute the value here. Okay. Then this is 0.7 into 6 and this is 410 and this is 1.25. Okay. So if you substitute the P value here, then only one unknown, that is length of weld. So you will get the length of weld. Okay. So this is the question. Okay. So next faculty will come.
Dear friends, let's solve FM questions. According to the students' data, we have 4 marks from fluid mechanics. If we include open channel, we have another 3 marks. Open channel 3 marks, total 7 marks from fluid mechanics and open channel. Let me take a one single question from fluid mechanics according to the students. See, he has given 2 reservoirs are connected by 2 pipelines. Let me draw the figure. These are two reservoirs are connected by two pipelines which are parallel. One is 600 mm diameter and the another one is 400 mm diameter. These are two pipelines connected in parallel. They are of same length and they are made up of same material. They are saying the length of these two pipes is same and they are made up of same material, means the friction factor is also same. Again they said follow Darcy-Weisbach equation. If you follow Darcy's Weisbach equation, head loss HF equal to FL Q square by 12.1 d to the power of 5. They asked what is the ratio of discharge through bigger pipe to smaller pipe. The ratio of, yes, they asked, let me take, this is pipe 1, this is pipe 2, 1 and 2. They asked Q1 by Q2, what is the ratio of discharges through those parallel pipes, right? If you frame the relation between Q and D, since we have a same length and same material, 12.1 is constant. You already know when pipes are connected in parallel, head loss is constant, so that this relation is discharge is proportional to d to the power of 5, right? Q1 by Q2 equal to d1 by d to power 5. Q1 by Q2 equal to d1 by d2 whole power 5. He has given d1 is, sorry, this is q square, q1 by q2 whole square. This is 600 by 400 power 5. If I want q1 by q2 ratio, this is 1.5 power 5 under root. The answer is closely 2.76. The options given in this question as, the options are 1.84, 2.76, 1.22, 0.54. The answer is 2.76. If you solve that, you will get 2.76 as your answer. Okay, the next faculty will continue the session. Thank you.
Now let's see the questions from open channel flow. We obtained 3 questions. So here the question, one of the question it is mentioned as a perfect free hydraulic jump occurred with a sequent depth ratio of 2. So the sequent depth ratio y2 by y1 is 2. Then what is the Froude number of supercritical flow? Supercritical flow means, so inlet Froude number FR1. Now that's the sequent depth ratio y2 by y1 is equals to minus 1 plus square root of 1 plus 8 FR1 square by 2. It's a straight away question. They have given the data. So substitute 2, bring this the 2 to the other side, minus 1 plus square root of 1 plus 8 FR1 square. 2 into 2 4, minus 1 5, square 25, minus 1 24, 24 by 8 3, and FR1 square is 3 then FR1 root 3, which is 1.732. This is question 1. Now in this question, now they have given the mass the following. So they gave two columns, column number 1 and column number 2. Column number 1 they mentioned as GVF profile, column number 1, and column number 2 they have given the nature of the profile. So now we have to bring down the codes. Now given that in the profile, in the column number 1, P, the GVF profile is mild slope profiles M1, Q, M2, R, M3. Whereas in the case of the nature of the profile, they have given that 1 as positive profile, 2 negative profile, 3 0, which means no profile. So from the given, the GVF profile in open channel. So now in the case of the mild slope, not only mild slope, you take any slope, always first and third profiles are rising profiles, which are nothing but positive profiles, and second profile is a falling profile, negative profile. So M1 is a positive profile, M3 also a positive profile, whereas M2 comes as a negative profile. So this is a question number 2 from open channel flow. And now next question. So this question is obtained from the average boundary shear stress in a wide rectangular channel. So the given data goes as, in a wide rectangular channel carries a flow at a depth of 1 meter. So the depth of the flow is 1 meter, and average boundary shear stress were given as tau naught, which is 10 Newton per meter square. If the acceleration due to gravity is given as 10 meter per second square, what would be the longitudinal bed slope? So they're asking about the longitudinal bed slope. Again, it's a straightforward equation. Tau naught is equals to gamma W into R into S naught. Whereas in case of the wide rectangle, R is equals to Y, which is equals to how many? 1 meter. So tau naught, average boundary shear stress, 10 is equals to gamma W, 10 kilonewton per meter cube. So 10 into 10 power of 3 into, as wide rectangle R is equals to Y, which is 1 into S naught. 10 will get cancelled. Then S naught is equals to 1 by 10 power 3, which is nothing but 1 in 1000. So these are the questions from the open channel flow. And so far and so good. We got one question from irrigation and we got one question from the hydrology. As we have not got the entire data, so let's see the available data. Now in irrigation, the question obtained was from duty. So straight, a simple question only. A canal has a discharge of 10 meter cube per second from source. So from the source in the canal, whatever the flow that sent is 10 meter cube per second. Now it is intended to irrigate an area. The field area of the area is 7,500 hectares. If the losses during conveyance is 50%, so the conveyance loss itself is 50%. If the conveyance loss is 50%, what is the efficiency? 100 minus 50, which is equals to 50, 100 minus 50, 50%. So by the time the water reaches to the field, you know the conveyance efficiency is whatever the field by source. Now flow rate at the field is equals to 0.5 into 10, that comes as a 5 meter cube per second. The flow rate that reached to the field is 5 meter cube per second. Now the question they're asking is duty of the canal at a field. So what is a duty? Duty means area by discharge, and the duty will keep on changes based on the location. Duty at source is different, duty at field is different. So when I ask the duty at the field, then A by what is the flow rate at the field, which comes as 7,500 by 5, right? So that is 1500 hectare per cubic. So these are duty at the field. If they would have asked you duty at the source, directly you can find out A by Q at source, which is 10. 7,500 by 10, that comes as 750. So for the given question, the correct answer is 1500 hectare per cubic. Now let's see the question from hydrology. Mind you, these are not the final questions, these are the questions that we got from memory base from the students. So now this question is from hydrology, and this question is about the drawdown of wells in an unconfined aquifer. In an unconfined aquifer, a pumping test is conducted using a well of a radius 20 centimeters. So now there is a ground level and there is a pumping well which is sitting on the hard strata. Okay. Now the pumping test is conducted using a well of radius 20 centimeters with the 30 meters depth. So the total depth, now let's assume this is a water table itself. The total depth is given as the capital H is 30 meters. Right. Now there are two observation wells which are located at a distance of 10 meters and 100 meters. So two observation wells are there from this point center. Let's take R1 is 10 meters and let's take R2 is 100 meters. Okay. Now they observed the drawdown at 2 radial distance. Definitely there will be a drawdown, right? So from here there is a drawdown. Now whatever the drawdown that observed at the 2 radial distance are 12 meters and 11 meters respectively. So at R1 the drawdown, let's take this as S1 which is 12 meters, and from here there is going to be S2 which is going to be 11 meters, right? The coefficient of permeability of an aquifer from the pumping well. So if the discharge is given as 68 meter cube per second, what is the coefficient of permeability? Now the given is a unconfined aquifer. Unconfined aquifer. As they have given the drawdown as 11 meters, whatever the leftover value this H2, there is going to be the 30 minus 11, 19 meters, and what about here H1 leftover water 30 minus 12, 18 meters, right? So what is the discharge? Discharge Q is equals to pi into K into H2 square minus H1 square by log base E R2 by R1. So everything is given. Now just substitute the data. So Q 68 is equals to pi into K into 19 square minus 18 square by log base E 100 by 10. It is not log base 10. 100 by 10, 10 log 10 as 1, but it's not log base 10, it's log base E. Don't get confused. So if you have solved, the answer that you obtained is 1.347 meter per second. If the question was asked as rounded to 2 decimals, then you can take it as 1.35, else you can leave the question answer like 1.347. So these are the questions from hydrology, and we also got some questions from the environmental engineering. Let's see what are the questions from the environmental engineering. So in case of the environmental engineering, so this question is obtained from the rapid sand filter, that too for backwash. A rapid sand filter bed of depth of 0.8 meters. So they have given the rapid sand filter. The initial thickness is given, the Z value is mentioned as 0.8 meters, and for that 0.8 meters the N value, the porosity is given as 40% during the servicing cycle. It is recommended that during backwash operation, so now we are going to do the backwash. Whenever you do the backwash rate is around 5 to 7 times of the rate of filtration. Obviously the bed will get expanded, right? The expanded bed, filter bed should have 70% porosity. So when the bed will get expanded, now this expanded bed ZE, so for this ZE they have given the porosity as 70%. The question is, what is the expanded depth of the filter bed during the backwash? So it is about the ZD. Whether it is the expanded bed or normal bed, during the backwash, the head loss during the backwash must be same. The head loss must be constant. What is the head loss during the backwash? Which is G minus 1 into 1 minus N into Z. This must be is equals to constant. And as G is always constant, now we can write down 1 minus n into z is equals to 1 minus ne into ze. So what we are asking is the expanded bed thickness. So ze is equals to 1 minus n, which is 1 minus 0.4 by, you send the 1 minus n to the other side, 1 minus 0.7 into 0.8, right? 1 minus 0.4, 0.6 by 0.3, 2 into 0.8, the answer is 1.6 meter. So they have given the options are 1.2, 1.6, 1.4, D as 1. The correct answer is option B. Now, so they asked a question. Actually, this question is given as a MSQ. Which of the following is / are not removed in secondary treatment of the sewage? So in secondary treatment of the sewage, okay, so 1 pathogens, the options mentioned are 1 pathogens, 2 settlable suspended solids, 3 fat and grease, 4 colloidal solids including dissolved organics. First of all, the secondary treatment is mainly to remove the soluble BOD. The soluble BOD is nothing but colloidal and dissolved. So secondary treatment is useful for the colloidal solids, but the question they are asking is not useful. The question is asking not removed. Which of the following are not removed in the secondary treatment? Definitely colloids or solids, they will be removed. Now pathogens, yes, obviously in the case of the secondary treatment, whether it is an activated sludge process or a trickling filter, at the end the bacteria will undergo endogenous respiration, where the bacteria will die down because lack of the organic matter. So we are going to remove the pathogens also. Now see the 2 and 3, especially the fat and grease. So option A incorrect, option 4 also incorrect. Now fat and grease. Fats and grease we are going to remove, especially in the case of the preliminary treatment, not even in the primary treatment. So we don't remove the fat and grease in secondary treatment. Now coming to the settlable suspended solids. See, in the case of the wastewater, there are different type of solids. Settlable solid, suspended solid, dissolved and colloidal. Settlable solids are the solids they can settle on its own if you leave it for 2 hours. So most of the percentage of the settlable solids will be removed in the case of the primary clarifier of the primary sediment, primary treatment itself. Whatever the leftover finer suspended solids, that will be removed in the secondary treatment. So settlable solids will be mostly removed in primary. They are not going to be removed in the secondary. From the given options, the correct answers are 2 and 3. Now the next question. Settling velocity of an inorganic particle in sedimentation tank of a water treatment is governed by. See, the inorganic particles in sedimentation tank, those are nothing but the suspended solids, which are discrete particles, and those discrete particles, that is based upon the Stokes law. They have given the answer options: Stokes law, Dupuit law, Bernoulli's law. Out of those, the correct answer is the Stokes law. Now this question, average settlement from a city is 90 mld. Average settlement from, average sewage from a city is 90 mld. So the discharge is given as 90 mld, and 5-day BOD is mentioned as 300 mg per liter. The average domestic sewage rate, so average domestic sewage rate, let's take that as a 0.08 kg per day per person, or also we can call it as a per capita BOD rate. Per capita BOD rate. What they're asking is a population equivalent, P dash. Again, it's a textbook equation. So population per capita, population equivalent is nothing but what is the mass of BOD generated by per capita BOD rate. So like domestic sewage rate. Now what is the mass? Mass is nothing but product of the discharge into BOD, which is Q into Yi by domestic sewage rate. So now substitute these values, which is 90 into 300 by 0.08, you will be getting as a 3,37,500. So there are options over here. The option is option 4, 3,37,500. These are the questions that so far we obtained from the hydrology, irrigation, environmental engineering and open channel flow. The next questions will be dealt by the corresponding faculty.
So from the general aptitude, we are getting some questions from the students, purely memory based questions. Okay, out of the memory based questions, we are getting, once see the questions here. First one, missing number wise question, missing number point of view. What is the number? Okay. Okay, my dear students, easily you are getting the answer for this question, I hope. Okay, so you can observe here, triangle inside 6, square inside 24, pentagon inside 120. Here hexagon given, 6 sides, hexagon given, what is the answer? So 99% students, you are getting the answer. Okay, so here 3 sides means it is called 3 factorial. 4 sides, 4 factorial. 5 sides, 5 factorial. 6 sides, 6 factorial. 6 factorial, then answer is 720 is the answer, my dear friends. I hope everybody getting this answer. And next one more question, simplification concept. Okay, where P and Q are positive integers, P and Q are positive integers, and they given a relation P square is equal to Q square plus 13. Find P into Q, product of those variables, product of those variables. So P square is equal to Q square plus 13. Okay, friends. So P square, then P square minus Q square is equal to 13. How can you write here? P plus Q into P minus Q, P minus Q. So 13. So product 13, my dear friends, product 13 means it is a prime number. Prime number means 1 and itself, right? Okay, 1 and itself. That's the reason we can take 1 and 13 only, your wish. So P plus Q is equal to 1, P minus Q, okay, is equal to 13. You can simplify. So 2P is equal to 14. So P is equal to 7, P value 7. Then obviously Q value, P plus Q, Q value is equal to 6. I want P and Q. So P and Q, 7 into 6. So answer 42. Okay, this one also very easy. Okay, very easily we are getting the answer, my dear friends. And next, third one, from the time and distance. From the time and distance, a person cover 3 equal distances. Okay, 3 different timings given. 3 equal distances means 2 kilometers. These 2 kilometers sometime, these 2 kilometer sometime, again next 2 kilometer sometime, in terms of minutes given. Okay, in terms of minutes given. So these 2 kilometers, what is the time? Here these 2 kilometer 4 minutes, here 5 minutes and 8 minutes. What is the average speed of the person? Okay, so average speed means number of times we discussed. Average speed, total distance by total time. So 6 plus total distance, 2 plus 2 plus 2. Total time 4 plus 5 plus 8. So here 6 by 17 minutes. These minutes convert into hours. Okay, 6 by 17 into 60. 17 by 60 converted. So 6 into 60 upon 70. Approximately answer 21.1 etc. Approximately answer. So easily we are getting this one also. Maybe 1 mark question here. And next, fourth one, 2 mark question. This is 2 mark question. There is a 2 equations. Number of intersecting points. Number of intersecting points. They given 2 equations. First one, y is equal to x square. Second one, y is equal to minus x square minus 2x minus 5. Okay, how many intersecting points possible? Options also given. Option A 1, 0. Option C 2. Option D 4. Okay, 4. How many intersecting points possible? Okay, so you can take a graph, x-axis and y-axis. Y is equal to x square, everybody knows. Okay, y is equal to x square graph, everybody knows. It is a even function. Okay, it is a even function, everybody knows. Y is equal to x square like this. Second one, y is equal to minus x square minus 2x minus 5. Okay, I don't know diagram. Okay, how can you go? How can I solve? So first, instead of x, I take a 0. Instead of x, I take a 0. I take a 0 means 0, 0, minus 5. Okay, minus 5. If I take a x coordinate 0, answer should be y value minus 5. So the position here, first point. Suppose I take a 1. I take a 1. Okay, 1 minus 1. Here minus 2, minus 5. So minus 8. So nearby 8 here. Okay, 8 here. So the diagram possibility like this. If you take a minus 1, if you take a minus 1 means, okay, again 1 it is minus 1, it is a plus 2, minus 3, okay, minus 5, minus 5, so minus 6, minus 4 we are getting, answer minus 4, so somewhere here, okay, somewhere. So we are getting this type of diagram. Then intersecting point, is it possible? No. So then what is the answer? B is the answer. Already number of times mentioned, graph type of question given in our examination is they kept 2 marks in our hand. So already in our hand 2 marks. Okay. Next, last one. From the mensuration, number of times, you know, mensuration guarantee question. So they given a diagram, circle, diameter. From the center, okay, we take a 2 triangles and join these 2 sides also. P, Q, R, P, Q, T. They given, this is R, this is given S. Requirement is this one. Requirement is this one. What is the requirement here? angle PQ, PTQ. This is the requirement. What is the T? Here angle, what is the T value? And they given one more information here. They given one more information. Okay, so mensuration question, my dear friends, 99% is everybody solving. Everybody, very easy, very easy. So they given this one 80 degrees they given. Next, look at friends, all of you. This one completely 180. Okay, you know 180. So suppose first initially I take x, this is also x, because it is a, this is also radius, my dear friend, this is also radius, 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 everything also radius only. Okay, everything is also radius only. Suppose I take this is radius, okay, radius, this is a radius, this is also radius. Okay, two sides equal, isosceles triangle. Okay, isosceles triangle. Okay, isosceles triangle. You can add the, first of all, we are getting here 180. This is isosceles triangle. Obviously, you are getting, you can simplify, you are getting the answer. So 2x plus 80 is equal to 180. Okay, 180. Then 2x is equal to 100. X value 50, right? X value 50. So this one 50. Obviously, this one also 50. Okay, so isosceles triangles, isosceles triangle. Okay, opposite side, opposite angles equal. So this one 65, this one is 65. Okay, this is also 65. This is also 65. Same. Okay, same reflection, like a symmetry figure. So now what is the question here? You can observe, friends. PTQ. It is a triangle. It is a triangle. So sum of interior angles. So sum of interior angle of the triangle 180 degrees. So already you know these two values, 65, 65, you know. This one theta is equal to 180. So then theta is equal to, okay, 65, 65, 130. So 180 minus 130, that is equal to 50 degrees. Within the 2 minutes, I think you are able to solve this question also, my dear friends. Okay, these 5 questions we are getting memory based from the students only. Next, I'll continue with the next faculty. Keshav Reddy sir will continue.
Hi students, 2 more questions from the students feedback. This one is from RCC, a very common question, not a new question. It is based upon the spacing of reinforcing bars in slab. Usually the spacing is inversely proportional to area of cross section of the bar. More the cross sectional area, more the spacing will come into the picture. Say what's given is 10 mm dia, bars are used in a slab with 150 mm center to center spacing. In place of 10 mm bars, if 10 mm is not available, they have gone for 12 mm bar. What should be the new spacing? So diameter is increased, means spacing between the bars may increase, because more area, more spacing. So for this 10 mm, this is the area of the bar, 150 mm center to center distance. And for 12, pi by 4, 12 square, what is the spacing they are asking? So it will be taken as pi by 4 can cancel. So 12 square by 10 square into 150. After cross multiplication, 12 square into 150 by 10 square will be that question mark. It's approximately 216 mm. If you are using 12 mm bars, 216 mm center to center is the spacing, and it is not exceeding the maximum spacing given by IS 456. So the answer will be 216 mm center to center as per the data. Such a question came in local service examination also, local service commission examination also, but appeared now in GATE exam. There was a transportation question given based upon the Marshall mixed design method. Marshall mixed design method. They have given theoretical specific gravity of the bituminous concrete mix as 2.43. Theoretical specific gravity is specific gravity of all ingredients along with bitumen without air. The bulk specific gravity is given, this is a specific gravity with air. They are asking you percentage air voids. The air voids in percentage is theoretical specific gravity without air, bulk specific gravity with air with respect to theoretical specific gravity into 100. If you substitute the data and simplify, it is 9.46%. So the data whatever I am giving you is based upon the student memory recollection. So there may be chances of slight changes, but just for procedure point of view, I am giving you this data. Okay. So if the other questions are coming, we'll continue with the other questions. The next faculty member will take up the next question in the next subject.
So we got one more question from the environmental engineering. This is from the activated sludge process. So they have given the data for the aeration tank and the secondary clarifier. Now the data goes as, I am representing all together in the figure itself. So there is an aeration tank. Now whatever the influent rate into the aeration tank given as 20,000 meter cube per day with the inlet BOD as 250 mg per liter. Now the volume of the aeration tank is given as 6,000 meter cube with MLSS in the aeration tank as 3,000 mg per liter. Now after the biological treatment, once the wastewater is sent to the secondary clarifier, in case of the secondary clarifier, the effluent BOD is observed as 20 mg per liter. With the underflow, out of that underflow, whatever the flow rate, that certain amount of the flow rate has been returned to the aeration tank and certain amount of the flow rate has been wasted out. Now the returned flow rate is mentioned as 6000 meter cube per day. What would be the wasted sludge flow rate from the system? QW. If the biomass sludge retention time, it is also known as mean cell residence time or sludges, altogether that is nothing but theta c, which is given as 6 days. On top of it, it is already mentioned that the MLSS in the influent and effluent is assumed as 0. Whatever the MLSS in the influent and effluent, you are going to assume this as a 0. So what is the question that we need to find out is the wasted sludge flow rate. It's in this. First let's see about the theta c. In case of the theta c, what is the sludge is? The theta c is nothing but mass of solids in the system by mass of solids wasted from the system. What is the mass of solids in the system? V into x by the mass of solids wasted from the system, means from the effluent QEXC and QWXU. It is clearly mentioned that the MLSS in the effluent and influent are 0, so you can take XC as a 0. The question we require is a QW, right? Now QW is equals to V into X by theta C into XU. So if you look the data, we know V, we know X, and we know about the theta C. But what about the XU? XU is nothing but the underflow MLSS. We need to find out this underflow MLSS. How? Let's see. Now if you look into this, the equilibrium, whatever the returned sludge QR, it has a concentration of XU, and whatever the QI given XI is equals to 0. Now if you take that point, so influent QI with XI, returned QR with XU, both are going to be entered into the aeration tank. So QI plus QR into X. Now Q in must be is equals to Q out, right? So from here QI XI plus QR XU is equals to QI plus QR into X. It is mentioned that assume that influent MLSS are going to be 0. So this is going to be 0. Now what you require is XU, right? XU is equals to QI plus QR. QI is given as 20,000 plus QI is given as 20,000 and QR is given as 6,000. 6,000 by QR, 6,000 into X value as a 3,000. If you find it out, you will be getting that XU value as 13,000 mg per liter. 13,000 mg per liter. So once you know the XU, you can find out the QW. So wasted sludge flow rate QW is equals to volume of the tank is given as 6,000 into X is 3,000 by theta c given as 6 days into 13,000. After solving, you will be end up with the answer as 230.77 meter cube per day. Mind you, whatever the data that we have provided, so this is from the memory based only. There might be some errors also. The final solutions will be uploaded within a few days once we get the final paper. So I hope every one of you have attempted the question paper very well, and that's all from us. Thank you.